Can all hear me okay? Can you hear me okay? Okay. This is going to be a short meeting. So I just want to say a few things. First of all, I graded, for you folks, I graded the multimeter quiz. You know, most people did fine. There was just one issue, and this is typical for this lab, is when you measure the current. So some folks, they connected to the bulb like so. And then to measure the current, they proceeded to place the ammeter parallel to the bulb. And this is a no-no. Because now you've placed the meter in parallel with the bulb. Now, the multimeter has a low resistance. That means it allows charge to easily flow through it. So what do you think happens to the light bulb when I connect the ammeter across the bulb? What do you think will happen? Yeah, the light goes out. And so what will happen is when the electrons get to this point, to this junction, they have two paths to take. More of them are going to take the path of least resistance. Very few will go this way, most will go this way, so the bulb goes out. So now you're not measuring the true current through this bulb because there's no current going through it. Okay, everything's going through an ammeter, and what the ammeter is going to read depends on what the ammeter resistance is. And if you're in a 10 amp scale, the resistance is less than an ohm. So I had one student or two students in the two classes get like 7 amps. That would mean your wires would start getting warm. If this was your the outlet from your house, you would have blown the fuse to or you would have blown the circuit breaker. Okay. So you never do it this way. Okay. If you want to measure current, you have to put the meter in series. Whatever goes through the bulb goes through the ammeter. That means they get the same amount of charge per unit of time going through a bulb as you do for the ammeter. So it's got to be in series. And this thing has to have a low resistance, at least low compared to the bulb. And so the clue that you were doing something wrong was that when you hook up the meter, the light goes out. Okay, but some people didn't notice that clue. Okay. Some people, I had one person who put this on the AC current scale. So actually the bulb didn't go out. Okay, and the meter wasn't blown either in that particular case. Which I was surprised. Okay. But yeah, you always have to put it in series. That's really important for the next labs, the Ohm's Law lab, and also the DC circuit analysis lab. All right. And I guess the thing that bothered me was that I told all my classes to play with the simulation that's online. Because when you play with the simulation, if you hooked it up like this, you would see flames in the simulation telling you you did something wrong. Okay, but the people who did this wrong, of course, did not play around with the simulation. Okay, so the Ohm's Law lab is due on the 29th. And next week, I'm going to talk about DC circuit analysis. I'm actually going to talk about two labs, your next lab and your project, your lab project. Okay, the DC circuit analysis I'll introduce next week. It's on chapter 28. In fact, the circuit for this lab, I'm going to talk about in lecture. And so in lab, I'm just going to talk about the what you have to do for the experiment. Okay. And then this is your project. You have to build a motor. You have a motor kit in your lab kit, and you have to build it. Okay, so I'm just going to talk about what you need to do for the lab. And then when we get to the point where we're doing magnetic fields and we talk about torque, then I'll say a little bit more about the DC motor. So you have a little bit more information about this. And it is for this lab where our discussion board is going to be of use to you. I'm going to expect you, you're going to ask me a lot of questions about is it working or not. If it's not working, I expect you to ask questions in the discussion board. Okay? Because other students are going to have the same question. So this is due on December 3rd. The DC circuit analysis is due on the 5th, and then the Ohm's law is on the 29th. These two labs, you're turning in a hard copy. You're printing it out and handing it in to me. Now, this one's due on the 29th. It's the same day as an exam, which means that you actually have, if the due date falls on an exam date, I give you an extra day to turn it in, which would be the following Monday. But then you still have to come to campus and hand in a hard copy. I'm not accepting any emailed version. You are turning in, you're printing it out and turning it in. Okay? If you email it to me, I'm going to consider it late. Okay? All right. Since you're doing a written lab report, for some of you, this is a new thing. For those of you who had 205 last semester with Shakal, I have very similar expectations for the labs as she does. Maybe I might be picky about some things, that, some things or other. I mean, we might grade a little bit differently, but we have similar expectations. In fact, everyone in the department expects their lab reports to be typed. Okay. All the measured values that you report has to be reported to the correct number of significant figures. All measured values must be reported with correct units. And then check the tables in your lab reports because make sure the units are correct. And then you don't have to put, if you have a table, you don't have to put units with every cell value. You can just put the units in a column heading. That's sufficient. All measured values must be, all graphs require proper captions, titles, axis titles with the associated units. The data points on the graph must be clearly visible. Okay, I need to be able to see the data points. And on your graph, I only want to see one curve on the graph, and that's the curve fit. So most software, you can not only do the curve fit, but most software, when you plot the graph, actually, let me do this. Most software kind of does this. They connect the dots. I don't want to see that. I don't want to see the connect the dot. Don't enable the connect the dot features in the graph. You want to do a curve fit, you want the data, you want this. So I want to see this on the graph. I don't want to see that. So that's the only line I want to see. And then you're going to have title here with the units, and then title here with the units, and then title here, and then figure caption below. Okay, so I want to see all that in your graph. These are things I take points off for. And on your graph, I want to see the curve fitting parameters. With side tables, you can create a text box and then put your curve fitting parameters along with the uncertainties, just the raw values. And then later on in the lab report, you will write these values to the correct number of decimal places. When you write a number in scientific notation, those three values you see there, are improper ways of writing a number in scientific notation. I actually take off points for formatting, so I don't use that formatting. Your word processor can do superscripts and subscripts, so use that feature in your word processor. Never, ever, ever use the term human error. Usually when someone doesn't know how to answer a question regarding errors in the lab, they throw that in. Okay, that's very vague. Graphs, like I said, graphs must show the curve fit parameters and their uncertainties. And then when you're typing your lab report, you're going to use the equation editor, either in Word or whatever equation editor you want to use to type your equations. And if you need help with any of these things, I'm going to be on campus on Monday next week and on Friday. Okay, so it's up to you to come ask me questions. Don't wait till the last minute. Now, if you're asked to show work in the calculation, show the equation that you used, in the general equation, and then show the equation with the proper values substituted them so that I know you know how to use the equation. Now, I emailed you all a sample lab report. Please read through it. Gives you an idea of what I expect. When you're, and these are things that have happened, I guess, the last few semesters. If I give you a resource, like a video or simulation or whatever that's on Canvas in your modules, use them. Watch the video, use the simulation. They're there to help you complete an assignment. Also, in your labs, your shelf for your lab, your Canvas shelf for your lab, there's an announcement section. Please read the announcements. They basically have the reminders in these PowerPoint slide on there. Okay. Now, labs, because of the internet, people will post their old labs on the internet. Oops, sorry. If you copy a lab that's from the internet, you're going to get a 0 on it. If you fake lab data, you'll get a 0 on the lab, even if the analysis is correct. Okay? Questions on those? All right. So I just want to say one thing about the Ohm's Law lab, and it has to do with the diode part of the lab. Okay. So in the last part of the lab, you're going to plot for the diode current, the current through the diode as a function of delta V, the voltage drop across the diode. And the graph will look like this. It's exponential. This is the data from table 3. Okay, that's the data from table 3. And the theoretical expression for this graph, or for the I, is a function of the voltage drop across the diode is this. And we talked about it a couple of weeks ago. And I wrote down what V sub t was, and if you don't remember, just go watch the video. Okay. So you're going to do a curve fit of your data to this equation. This is the y-axis, that's the data on the x-axis. And then your curve fitting parameter is going to be this. This is called a saturation current. And so this will be a curve fitting parameter. okay? And this n will also be a curve fitting parameter. N equals 1, ideally, I guess. In the ideal case, or the theoretical case. But the real value, in general, n is a number between 1 and 2. And so you're going to collect like 28 data points or 30 data points, a lot of data points here. Plot that data. I want to be able to see the data points. You're going to fit your data to this equation in SciDavis. Or whatever software you want to use. I mean, you don't have to do SciDavis, but the software has to be able to give you this curve fitting value along with the uncertainty, and this curve fit value along with the uncertainty in that value. Okay? All right. And when the diode is set to really conduct in that direction, the diode is called forward biased. When you reverse bias the diode, in other words, in the last part of the lab, you're going to flip the diode over so it's backwards. So the voltage drop across will be negative, and so will the current through it. Very little current flows. So this is the data from table 4. Okay. Now, one of the problems with this last part is the multimeter only has a 20 milliamp scale. In order to actually get anything decent here, you need the microamp scale. Our meter doesn't have that. One of the meters we had last semester did have the microamp scale, but we didn't provide it to you this semester because we could not use it for the subsequent labs. Okay, so there's a trade-off. So it's possible that all these values will be 0 or like 0.0001 milliamps, whatever. Okay, so don't worry if all the values are 0. Okay, that's fine. But you might get one value or two values that are not 0. They'll be like 0.001 or 0.002, whatever. Just use those values. Okay? So when you do the curve fit, perform curve fit on table 3 data only. Okay? Perform the curve fit on table 3 data only. Because this will mess up your curve fit. Okay. And I put some links on the diode. I haven't really had time to really get into the diodes in general. There are applications, there's a lot of applications for diodes, but you can look at, there's a video and a page with information on the diode if you're interested in looking at it. We're just looking at its characteristics in this lab. Now, one last thing I want to mention is that when you take these measurements in table 3, you have to stay on the same ammeter, on the same scale on your ammeter. So there's two scales, two possible scales you're going to be using. Whatever scale you use, you have to be on that scale. Now, what you should do is figure out what the maximum current is. Okay, you need to figure out what the maximum current is when you do this part. So you have to play around with it before you take data. And then from that value, then you can figure out which scale you're going to be on. If the current is going to be less than 20, if the highest current is less than 20 milliamps, you can stay on the 20 milliamp scale the whole time. You get more sig figs. If the highest current is above 200 milliamps and less than, if the highest current is above 20 milliamps and less than 200 milliamps, then you got to use the 200 milliamp scale. the whole time for all the data points. Okay. Except here, you have to use the lowest scale here. Otherwise, for sure you won't get anything. All right. That's why I don't want you to plot I want you to plot it, but I don't want you to do the curve fit. Because this will mess up everything. Questions? Again, Ohm's law is doing the 29th. You really got to get started on it. I will be here Monday and Friday of next week to answer questions on this lab. Because on Friday, I want to talk about the next lab. And it is a very long lab in terms of the analysis. The data taking is quick, but the analysis takes a long time. That's why I want you to get the labs, get started quick on these labs. And after from 29th onward, we're meeting in person every week until the end of the semester. All right, so if you don't have any question, I'm going to end it here. You folks have a great weekend.
You too, thank you.